Alright guys, what is up? Welcome back to Minecraft with Lone Debater 7, and today I wanted to show off some redstone basic logic gates. Now, I've played with redstone before, and these are not super new to me. Like, I know, like, you've probably, if you played modded Minecraft, seen like an AND gate or an OR gate as a single block. I think that's from Red Power, or it might be called something different now. It used to be called Red Power. But anyway, I wanted to show you kind of how to build these in just vanilla Minecraft. The only thing I've added to this is just a Spax texture pack, because I like it better than the vanilla textures, but creative mode just so we can, get the blocks that we need to build these, and yada yada. But today, I kind of want to show off digital logic to you. With redstone, and what kind of sparked this is I've been learning about digital logic and binary and all that noise, and I thought a really cool way to visualize it would be try to build what I've learned inside of Minecraft with redstone, because you can apply these logic gates to do some pretty cool things. As an example, let's say you wanted to build a combo lock door or something like that, so you have to flip a specific 3 levers out of 5, for example, and only if the right 3 are triggered will it open the door, and if any wrong combination is entered, it'll deploy some sort of trap, something like that. Using these logic gates, you can make that happen in vanilla. Yes, you will need a lot of redstone, and you'll need, to figure out how to kind of map it out, but whatever. We'll probably do that in a separate video, but today I want to show off basic logic gates. Now, there's essentially 4 basic logic gates that you've got. You've got your OR gate, your AND gate, your NOT gate, and your XOR gate. So basically, with these 4 gates, you can assemble them in any combination you want. You can add more inputs than just the 2 that I've got shown on each one. It's completely up to you. However, the more inputs you add, the more complicated the redstone path lane is going to become, so just keep that in mind. But like, for example, on an OR gate, you could have 8, 10, 12 inputs, and that's totally fine. It's just going to get a lot more complex, and you're going to have to stack gates and do a bunch of crazy things. Anyway, let's go over just the basic OR gate, which is this fella right here. So the way an OR gate works is it's got at least 2 inputs, so we're showing basic 2 input OR gate, and it'll have 1 output. So when both levers are off, the output is off. If we flip one lever, the input turns on. If we flip the other lever, the input stays on. And if we just have this lever on, so the other input only inputting, it will remain on. So basically, if either input is a 1, if you're talking binary, when it's sending a signal, it's 1. When it's not, it's a 0. If either input into an OR gate is a 1, you're going to have a 1 on the output. And if both inputs are a 1, you will still have a 1 output. So that is the OR gate. We had to do something a little tricky here. We'll show that in a minute. Next, we've got the AND gate. Now, the AND gate, similar to the OR gate, starts out with a basic of 2 inputs and 1 output. And this one, it's only if both inputs are a 1 will the output be 1, otherwise it's a 0. So just to show you, if we only flip the right switch, we still don't have the output glowing. If we only flip the left switch, we still don't have the output glowing. But if we flip both of them, now we have the output turned on. So that is the basic AND gate. Pretty straightforward. This is probably what you would want to use primarily for your door system that we talked about at the start, because you can make it so only if the 3 inputs going into your AND gate are turned on will the door open. Otherwise, the other inputs maybe would go through an OR gate that would then trigger like a piston to open up the floor to deploy your trap. Just as an example. The next basic gate is going to be the NOT gate, which is this little fella here. Basically what a NOT gate does, it's also called an inverter. There's several names for all of these, so you can call them whatever you want, but basically any input that goes into a NOT gate will be flipped to the other state. So right now the state of this input is 0, however it's outputting as a 1. If we change this to the input being a 1, the output becomes a 0. So in order to actually build these OR and AND gates, just the way redstone works, torches are always turned on, and in order to kind of create your gate, you have to use a redstone torch in order to do it. So if you put a NOT gate on the end of just this little setup here, it'll output like it's an OR gate. However, if you don't have that, it becomes a NOR gate or a NOT OR gate, where basically it flips the output truth table of the OR gate by using a NOT gate on the end. So what I mean by that, your standard OR gate, if either input or both of them are turned on, you will output a signal, right? With a NOR gate, which is this guy here, if neither input is on, you will output a signal, but if either one is turned on or both of them, it will turn the signal off. So that is the NOR gate. Basically with these, since redstone torches are a default on state, you have to invert it one time so the inputs match the output. At least that's how I've done it. There might be a clever way to do it without, but whatever, it doesn't matter. I did want to show you complementary to the NOR gate. You've got the AND gate, which is a NOT AND gate, and basically what you do is you build your AND gate, which you will see this architecture here is the same as the AND gate, and then you just throw a NOT gate on the end. So now the output will be illuminated except for when both levers are pulled. So still illuminated, and now it's off. So that is kind of how that works. I'm just going to switch it to day quickly, that way we can see. And we've arrived at our last basic logic gate, which is the XOR gate, or the exclusive OR gate. So the OR gate over here, it's going to illuminate the output if either input or both inputs are a 1, whereas the XOR gate will only illuminate the output if only one input is 1. If both are 1, it will output a 0. So basically the way this works, if I trigger the right switch, the output is turned on. If I switch it to the left switch, the output is on. If they're both off, it's off. If we turn them both on, however, it will go ahead and turn off the output. So the way I designed this, and it actually took me a little bit because I was trying to think through the problem as opposed to just looking up a design, which there's plenty of them out there, I'm sure you can find, whatever. They're probably smaller than this as well. But you start off with just your basic OR gate. So the first part is basically the same as our OR gate. And then I pass it through an inverter here. That way the outputs match the inputs that I'm sending. And then in order to actually control, so when both are illuminated, it turns off the output, what we need to do is send a secondary signal into the inverter block here in order to turn off this torch. So to do that, I basically constructed an AND gate on top of an OR gate. So the OR gate is this lower level. As you can see here, the inputs go up these stair steps to torches, and these torches are connected across here with a torch on front. So this is your AND gate that's stacked on top of the OR. You've got two inputs. When both are illuminated, it will turn off this track. If only one is illuminated, the track will stay lit so it doesn't send a signal out here. So that is basically how I built the XOR gate. You just run, your output of the AND gate back into the inverter that's connected to your OR gate, and that makes it so when both inputs are illuminated, the output's still not illuminated. So guys, that is basically my coverage of basic logic gates inside of Minecraft using redstone. If you're familiar with digital electronics at all, you know that you can use these logic gates to do some pretty cool stuff as far as like binary and data management is concerned. So in our next episode, we're probably going to go over the creation and the redstone circuitry behind like the combination door that I was talking about, just so you can kind of see how you might go about applying these gates. But guys, if you enjoyed the episode today, be sure to like, comment, subscribe as always, and until next time, this has been Lone Debater 7, and we will see ya.